day one, we are going to put prisms and cylinders together into one formula. This is also on your blue sheets if you want to continue filling those in. We are skipping spheres. We'll come back to spheres later on in this unit, but that'll be towards the end. So we're going to start with, I want to say it's number 16 on your sheet, volume of a prism and a cylinder. So basically, what we do when we find the volume of a prism or a cylinder is we find like that two-dimensional area of the base. And then if you see right here, this is like building blocks. So we figure out what's the two-dimensional area of the base, and then we stack them up based on how tall they are. So really, it's area of the base times the height. And that is exactly this formula. Volume equals big B, which we know big B stands for area of the base, times the height of the whole prism. That's the entire formula, B times H. And then for cylinders, it's exactly the same thing, because we know that cylinders are just fancy prisms. So for a cylinder, instead of big B, we use pi r squared, because we know it's a circle, but essentially the same thing, pi r squared times H there. Okay? Nice, easy formula, prisms and cylinders, I believe are 15 and 16 on that sheet. Then, I didn't bring out my props today, I probably should have, but this is Cavalieri's principle. Cavalieri's principle says, if I take a stack of objects, remember I did this with like the colored pencils, if we stack up those boxes of colored pencils, we could find the volume of them by finding the volume of that prism. But then if I push over the stack of colored pencils to the side, I just shove it over, I didn't change the volume. All I did was shove it over to the side. So now that that's shoved over to the side, did the volume change? Obviously not. That means no matter what my prism looks like or my cylinder looks like, whether it's standing straight up or pushed over to the side, all prisms have a volume of B. B times H. And then if I take a look specifically at this middle one, the only thing that we need to remember is that the height for a prism or for a cylinder is not a slant height. It is a regular perpendicular height. So if it's a right prism, which means it's standing up straight, that's just the distance from base to base. However, if it's a prism that has been pushed over to the side, the height has to remain perpendicular to that base. So instead of being that slanted height, it's still going to be a straight up and down distance from base to base, and it's going to form that right angle. That's the only difference here. The formula doesn't change. We just got to make sure that we're looking at the correct height. Any questions on that? Let's talk units really quickly. Hopefully we know what the unit for volume is, but let me prove it to you really quickly. If I think about the volume of a prism formula, let's say that I have a prism. Oh gosh, can I draw? Let's say that I have a prism, and this is a really good prism, but its bases are meters by meters, and then it's some meters tall. Then the volume of a prism formula, big B times H, the base would be represented by meters times meters, and the height would also be represented by meters. And if we think about what that unit is, that means I'm looking at meters cubed, right? So that's prisms. All prisms are going to have that base times width times height for a volume, which gives us meters cubed. Same thing if I do volume of a cylinder. Again, I'm thinking pi r squared times H. The radius of my cylinder would be something in meters, so pi times meters squared. The height would be in meters. That's just pi meters cubed. We're looking for that cubed. Just make sure that all of your units in this unit are units cubed. Good? Okay. All right. Let's flip it over. Number 1. What shape is this? Some of us were getting this wrong on the test, so I want to make sure we know what shape this is. Caitlin. This is a triangular prism. Remember I had you draw this net? So we want to make sure that when we name shapes, we understand triangular prism versus, I saw a lot of rectangular pyramid. We know this is not a pyramid because it's got 2 bases, right? And it doesn't come to an apex. It doesn't come to a vertex. So I know this is a prism, not a pyramid. Okay, so then I need to find the area of the base, that's big B, times the height of the prism. Area of the base formula, my base is a triangle here, because it's a triangular prism. And I have two formulas to find the area of a triangle. The first one works for every single triangle, 1/2 base times height. And the second one only works for equilateral triangles. This is an equilateral triangle. All three sides are 14. That other formula is 1/2 apothem times perimeter. You could use either one here, but just know you can't use the 1/2 apothem times perimeter unless it's an equilateral triangle. So kind of up to you what you want to use in this case. I would just split this right down the middle and call this the height. When I split that triangle down the middle, I create a 30, 60, 90 triangle. And then if the base split in half is 7, then the height would be 7 radical 3. So then to use my formula, 1/2 base times height here, 1/2, the base is 14, and the height is 7 radical 3. It might be useful to note that these two heights, this height right here, is not the height of the prism. This is the height of the base. So a very common mistake that I see is that some people would try to plug in this 22. 22 is the height of the prism, not of the base. That goes right there. And then don't bother trying to simplify this. Like, don't waste your time trying to simplify it. You can put this whole thing into your calculator. We're going to end up with, if you did keep it in exact values, this would be 1078 radical 3, which I'm happy with exact values, or you can just go straight to the decimal answer, 1867.2. Our unit is centimeters cubed here. That's it. That's the whole process for volume. Area of the base times the height. Any questions on that? Okay. I'm going to make things tricky just for fun. So look at number 2. Number 2 says find the cubic yards of cement that are required for a 60-foot long driveway that is 8 inches thick and 20 feet wide. So if you recall way back in Unit 11 when we talked regular area, we talked about the ratios between lengths, perimeters, areas, right? So I've got a whole bunch of different units in this problem. I have yards, which is what it wants my answer in. Some of these dimensions are labeled in feet, and the thickness of that concrete slab is measured in inches. So the very first thing we need to do is I need to convert my units. And the reason that I'm doing that first is because if we remember from that lesson in Unit 11, that the ratio of side lengths is not the same as the ratio of areas. The ratio of volumes is exactly the same. Well, it's not exactly the same as the areas. It's a different ratio, but it's the same way. We can't just do all of our multiplication and then convert it at the end. We have to convert first. So I'm going to convert to yards because that's what it wants my volume in. The first thing that I'm going to do is convert this 8 inches into feet. To get from inches into feet, I'm dividing by 12. So that's 2/3 of a foot. And then to get from feet into yards, there's 3 feet in a yard. So I'm going to divide that by 3 to get 2/9 of a yard. Which is a crazy fraction, but we're going to leave it like that. Same thing for these feet. I'm going to divide everything by 3. This is 20 yards. And then this one, again, a crazy fraction here. This is 20 over 3 yards. If you want to put that as like a mixed number, that's fine, but I'm just going to leave it. Okay, good. We're converting first because I know that the conversion is not going to be the same at the end. I can't just divide by 3 at the end and call it good. The base of this shape is a rectangle. It's a rectangular prism. So I'm going to do base, 20 over 3, times height of that rectangle, 20, times the height of my slab, which is 2/9. We can do this by hand. I know we can. 20 over 3 times 20 over 1 times 2 over 9 gives me 800 over 27. We can convert that to a decimal. That would be, where did I put it? 29.6 cubic yards. Any questions on that? Okay, awesome. All right, I'm going to keep making it trickier. We're not going to take it easy here. Number 3, I've got a shape, and it's got a hole punched out through the middle. This whole interior is hollow. There are kind of 2 ways that I can do this. We talked about these 2 different ways when we talked about like finding areas. Remember I told you there was like the building block method versus like a hole puncher method. Building blocks where we're adding pieces together, or hole puncher where we subtract pieces from one another. Let's do a top-down view of what this shape looks like on the base. So this base is like an 8x8 base, and then it's got this hole cut out in the center. I know it's kind of hard to see, but it's saying that each one of these sides is 2 inches thick. That means that that little shape in the center here, if I subtract 2 and 2 from 8, this little shape in the center is a 4x4 rectangular prism. Okay, good? So if you wanted to split this into a few different shapes, find the volumes of them all and add them together, that's totally up to you. I think the easier way, in my opinion, for this problem is to do the hole puncher method. The hole puncher method would say that the whole volume is going to be equal to the volume of the big prism, and then subtract the volume of that hollow piece on the inside. So, the volume of that big prism, the area of this base is 8x8, and the height from base to base here is 14. That's the volume of this big prism. Minus the volume of the hollow shape, which is a 4x4 base with the same height. It goes all the way through. 8x8 times 14 minus 4x4 times 14. It's going to get us a pretty nice number. It's going to be 672. Good? If you really wanted to split this up, you could split this up into like 4 different shapes here. You could do a shape here, a shape here, shape here, and a shape here. Up to you. Whatever you like to do. Okay, moving on. Number 4, here's our Cavalieri principle. This is a cylinder that's been pushed over. Again, because I pushed it over, the volume hasn't changed. It's just pushed over to the side a little bit. The area of the base is obviously a circle, so that's going to be pi r squared. The radius of this cylinder is 4. So this is pi 4 squared for the area of the base. The height of this cylinder, of this oblique cylinder, is the part that is a little bit tricky. Remember that we're not talking slant height here. Slant height is only for cones and for pyramids. The height is perpendicular to the base. So it goes from one base to the perpendicular to the other base. So that height is 16. Any questions on that? That's the trickiest part about oblique prisms and cylinders. 4 squared is 16. 16 times 16, 256. So 256 pi in exact values. If you want to round that, 804.2 meters cubed. That's literally it. One more. Number 5, same deal. It's a cylinder, pi r squared times h. The radius is 2.5, so pi times 2.5 squared. And then the height, here's the tricky part. Again, I'm not talking about the slant height. I don't care about the slant height. There is no slant height for prisms and for cylinders. What I care about is the distance from base to base. So I don't want to see you call the height 5 because that's the distance from the bottom to the top. I don't want to see you call the height 13 because that's slanted. The height is this distance right here. How am I going to find that distance? Dahlia. And what is the length of this side right here? Perfect. There's 2 radii together. That makes 5. So 5 squared plus h squared equals my 13 squared. Maybe you know that that's a Pythagorean triple. The height is 12. Good. Plug it all in. Exact values is 75 pi, or approximately 235.6 inches cubed. That's it. Any questions?